The Hypoid7 CNG filling station. It's about ready to start. It's preparing itself for startup. It does a self-test as well during startup and during its run condition. Right now the coolant pump is running. It's the first thing that starts, looks for pressure and flow. And once that's achieved, it times out, and then the gas valve is open after it does a blowdown sequence. The blue light's flashing because the oil pump is energized now, looking for pressure and flow. These are independent pumps. Now the machine's running. HMI screen is very comprehensive, showing all kinds of pressures, temperatures, anything that's off, or say a filter isn't in right, it'll show that, air filter. There's all kinds of settings on here, and for right now we got it set for half a GGE. It's going to run until that's complete. I'm going to back away. You see that vertical yellow tube? That's the high pressure reactor dryer system that strips out non-compressibles, sulfur hydrides, oils, water vapor. Does that under high pressure, and this is it's kind of a technology I developed. They call it the pulse technology, where it's pressurizing the pellets, the desiccant, and then it's suddenly releasing that pressure, and you'll see a swing. You also see a blue light indicating that the reactor is draining the non-compressibles, which are going into the blowdown tank system located inside the dome. And that also is testing to make sure the valves are working on that particular cycle. You could see the swing of these gauges and these nitrogen tanks, because the reactor is charged at a 35 to 3700 psi. That's one of the best pressures to certainly take the moisture out. And when the valves open and close to relieve that pressure, you see a low pressure reading actually on the gauge, but you see that pressure swing, and that's the pulse. The pulse, because the valve is opening and closing, and that's cleansing the desiccant pellets in the reactor. Those little red lights that you see around the acrylic ring, those are pressures that you could read visually from the pressure transducers, each one of those. You see the inlet filter there in blue. There's an electronic gas valve which works with or without any electric power. Say if there's a power failure, there's a battery backup to close that. And we're going to look inside the electrical cabinet. You can see some of the systems electrically monitoring and controlling the machine. There's a communications device, which there's a little round antenna on the side there for GPS, so we know where the machine is. Once it's installed, we lease the machine, we can keep track of it. Communications with the cell tower. You can see when it's running that periodically you see changes in pressure and blowdown stations running at various times. We're open opening the side cabinet on the machine to show some of its systems and subsystems that are in there. The motors are direct drive. In this particular case, we have dual motors powering the main compressor. These are the gas detection in different zones. This is zone 2, which is a network gas detection system. We have different vessels that store oil and non-compressibles where they end up back into the system. Different levels where we can read if there's water in the oil in a safe mode, and if it reaches this point, then it should be drained out. If the water builds above that, the level of oil and water combined can exceed a certain limit, and we look for that, and it would indicate a hard alarm, stopping the machine and notifying the user that there's an issue. He doesn't have to worry or wonder about it. Everything in the information center and the HMI tells you exactly what's going on. And this is a 1/4 horsepower motor for the oil pump. And inside here there's a fan, a high velocity fan, 3800 CFM, that runs and generates a pressure inside the cabinet, lower cabinet, to dilute any gases and force it up through the top of the machine and out the chimney going out there. Now we're at the other side, the other cabinet here, in which you can see this is the coolant pump, separate. One of the main drive motors and a larger main drive motor for direct drive to the compressor. This is the oil cooler. Again, high velocity fan. It's flushing with atmospheric gases and pushing that air on the oil cooler to help keep the oil cool. And this is a battery backup for the gas valve in case there's a power failure during an occurrence in which the valve needs to be closed. It's driven by that. If the battery gets weak or runs low, it runs through a self-test every time that battery is used. Okay, we're going to show you inside the main compressor unit. We're going to take the top off and show that. Okay, we took the dome off, the stainless dome, and the acrylic ring. The acrylic ring is about 20 millimeters thick, so it can protect against shrapnel, anything that may occur from the compressor itself. It can get absorbed into that very thick protective ring. You can see a lot of pressure transducers with digital readouts on there. For instance, this one is reading suction pressure or blowdown tank pressure. This is suction pressure. Stage 4 pressure. It's not running right now. This is stage 3. We have inlet and outlet temperature thermistors. We have this is stage 2 pressure. Notice that we have highly conductive materials on these higher stages. You see the oxygen-free copper, say on stage 4. Stage 3 runs cool. We didn't incorporate it there. It wasn't necessary. Stage 2 here with copper. Stage 1. This is reading oil pressure. And this one here is reading coolant pressure. So every stage, of course, has mechanical pressure relief valves. And this is a 10-piston system that I developed which is radial based, and it's quite compact actually for its performance. Maybe 20 inches in diameter and about 6 inches high, and it puts out a lot for its size, and it runs at very high velocities. We're able to tightly control everything because of its small size. We can run it at very high speeds, and we flush the system with a lot of coolant type lubricant, and lubricates it. There's all the moving parts have pressurized oil running to them. And if you notice here, there's a gas meter, which is not there just to look at it. It has a photoelectric eye that measures, that takes a pulse from the meter, and the amount of pulses indicates what its output is, and that gets calculated as far as cubic feet and then GGEs per hour and so forth. When the stage 4 comes out, we have a cooler at the top, basically a coil, before it runs out to come out of the back of the machine and get distributed through a high pressure hose with a disconnect coupling in case a person drives away when he's filling, say, his vehicle. This is the gas valve. It's electronic. So inlet gas, any alarm that occurs that's a high level alarm, automatically shuts the gas off, which again has a battery backup. We also read the gas quality coming out of the reactor, and we get a dew point measurement on that, which is technology that was developed in the UK utilizing gold contacts. Also inside, there's a lot of trade secrets about this development. Again, running very high velocities with no valve issues, no springs incorporated into it. There's a lot of other things about it. Certainly it's liquid cooled. The machine, when it's off, it's in a hibernate mode, we call it. And what happens is, say it's out in somewhere cold and gas has moisture, it could freeze, and when you start up it could be a problem. So the machine will maintain its temperature by turning on the coolant pump and heating that coolant, bringing it up above freezing, stopping that pump, and so the machine will always be at above freezing temperatures, so there's no accidental startup if the machine is cold and could cause a problem with valves. Same thing in say in Arizona, where it's very hot on a hot day. The machine's running and it's programmed to run, say, 10 GGEs, and during that run it gets real hot, gets over 200 degrees, it'll stop, it'll turn on the coolant pump, it'll actually continue to run that coolant pump and turn on a fan, an electric fan, which blows through the radiators, brings the temperature down. The machine, when it gets down, the machine resumes, starts up again, and keeps running until either the session's complete or it overheats because of extreme hot air. It'll keep resuming until it finishes the cycle, despite the temperature, hot or cold. That's why the pumps are electric, both coolant and oil. So if the machine starts up, it never doesn't have oil or oil pressure because it won't start. The oil also may turn on depending on the temperature if the machine is off, just to keep the oil up to temperature with the coolant. You never know where the machine's going to be, if it's in Saudi Arabia or wherever it is, in hot or cold places like Alaska. These systems even become more important. So this is a little briefing on our Hypoid7 CNG filling station. We hope you like it. Thanks.